question 11.3, which is solving radical equations. Well, a radical equation is just an equation, which means it has an equal sign, and there's also a radical in it, which is a square root. Now, we've talked a little bit before about what mathematically is the inverse of taking a square root. Squaring. And vice versa, the opposite of squaring is taking a square root, right? So if we want to get rid of a radical sign and it's a square root, we do it by squaring both sides. And I say both sides is because these are equations. And remember, the law for equations, since we were first learning how to solve equations, is what we do to one side, we must do to the other side. Whatever that is. Maybe it'll go away. Oh, okay. I've got a hair in my mouth that's stuck to my lip gloss, y'all. I think I got it. So, the first one, radical x equals 4. If I want to get rid of that square root, I square both sides. What you do to one side, you have to do the other side. So that's the most common mistake on this lesson is people forgetting to square both sides. So the square and the square root cancel each other out, and you're left with the underneath, which is just x equals, and what's 4 squared? 16. And you can check yourself, is the square root of 16 equal to 4? It is. Okay. There's a stupid hair again. There it is. All right, so B says the square root of x plus 1 equals 5. So notice that the whole entire left-hand side is under a radical. So if the one whole side is under a radical, go ahead and square both sides to get rid of the radical. So we square both sides. So the square and the radical cancel each other out. So you just write down what's on the inside, which is x plus 1 equals, what is 5 squared? 25. And then you solve that little bitty baby equation. How do we solve that little bitty baby equation? Subtract 1 on both sides, and x equals what? 24. All right, any questions so far? That seemed pretty easy. All right, so on problem C, notice that you just don't have a radical by itself on problem C. So you got a plus 8 after it, and that plus 8 is not underneath the radical. So the first thing you want to do when you have an option to do so is move everything away from the radical before you square both sides. So how do you think we can get rid of that plus 8? Yes, so before we square both sides, we want to subtract the 8. So then we're left with the radical x minus 3 equals what? 7. And now once the radical is completely by itself, then you can square both sides. So we're going to square both sides. Cancel the radical and the square. And we have x minus 3 equals what? 7 squared? 49. So then what do we do to both sides? Add 3. And what's 49 plus 3? 52. Any questions? Okay, likewise on problem D, we want to get the radical part completely by itself before we square both sides. So what do you think we're going to do first on problem D? Add 16. So that's 2 radical x equals 16. Is the radical completely by itself, though? No. So what can we do now? Yeah, that's 2 times radical x, so we can divide by 2 to get rid of the 2. So that's radical x equals what? 8. Now how do I get it to be just x? Square both sides. Cancel, cancel. X equals what? 64. These aren't so bad, are they? Just you wait. Okay, so E, same thing. We got stuff around the radical we have to get rid of first. I'll let y'all write that down for a second. Somebody's throwing pencils back there. All right, so what do you think we're going to do first to get the radical by itself? Subtract 12. So that's 4 times radical x minus 7 equals what? 16. Now what do I do? Divide by the 4. So that's radical x minus 7 equals, what's 16 divided by 4? 4. Now what do we do? Square both sides. So the square and the radical cancel out. So I have x minus 7 equals what? 16. Then what do I do? Add your 7 to both sides. And x will equal what? 23. Any questions there? Now, that problem F just went and ruined everything. Because there's a radical on both sides of the equal sign. Y'all see that? Darn it. So if there's a radical on both sides of the equal sign, you just go ahead and square both sides. Okay? Go ahead and square both sides. And I'm going to use parentheses. Because when I square both sides, I don't just square the radical parts. I square everything on that side. So that 3 outside the radical also gets a square. Does that make sense? So I can't just say it's 3 times 2. It's 3 squared times 2. Does that make sense? So 3 squared is what? 9. And the radical and the square cancel and leave you with just what? 2. So that's 9 times 2. Does everybody understand why that side is 9 times 2? So if there's a number in front of the radical, you have to square that number. Equals, radical x squared is just x. So all I have to do is multiply 9 times 2 and get what? 18 equals x. Now x is completely by itself. So if there's a radical on both sides, go ahead and square both sides. So look at G. Write it down. Radical 3x minus 17 equals radical x plus 21. So what do we do if we start out with a radical on both sides? Go ahead and square both sides. And the square cancels out our radicals. So write down the insides. 3x minus 17 equals x plus 21. And then we solve that. Let's get our x's together. How do we get our x's together? So I'm going to subtract x. So what's 3x minus x? 2x minus 17 equals 21. Then what do I need to do? So 2x equals 38. Divide by 2. X equals what? 19. Not too bad, is it? Questions? Okie dokie. What about this h? But they got a minus between them. Because if I square that whole side, that means multiply them times itself. Right? It'd be a binomial. I don't do that. But there's somehow I can rearrange it. Yeah, add the second radical to both sides. Because what happens when I do that, it's just a 0 over there, isn't it? So then I have a radical x plus 4 equals radical 2x minus 1. And don't that look similar to problem G? Yeah. So now I have one radical on both sides. So what can I do to solve for x? Square both sides. So y'all try that. I'll let y'all finish it. And then I'll work it and we'll check it. All right, so you squared both sides, right? And you canceled the radicals and got x plus 4 equals 2x minus 1. And then I'm going to subtract x on both sides, and I'm getting 4 equals x minus 1. And then I add my 1, and I said 5 equals x. Did y'all get 5 for your answer? Raise your hand if you got 5 for your answer. All right, we can still solve equations. I was just checking. All right. Next, we have a definition. And if you are at the bottom of a piece of paper after you write this definition, you might want to flip to another side or get out another piece of paper. Just warning you. So an extraneous solution, that's a fun word, extraneous, is a solution you get when you work a problem, but it does not fit back into the original problem. So if I plugged it back into the original problem, the answer I get, it's not a true statement. Okay? So extraneous, it's easy to think about that by looking at the first few letters of the word extraneous. What does that spell that I'm putting a box around? Extra. Okay? So an extraneous solution is like an extra solution you get, but it's not a real solution because it's not true in the original problem. So what we have to do when we solve these next few is we're going to solve them for x, and if what we're going to test our solutions, and if they're not true in the original problem, then they're extraneous, and we don't count them as part of our answer. So, like I said, if you're on the bottom of a piece of paper, you might want to flip over because these are about a half a page apiece. It will take up my whole screen. I'm not even lying. Yes, I promise this is Algebra 1. Okay, so I got a radical by itself. So what do I do to get rid of my radical? Square both sides. So now I have an x squared on the left-hand side, correct? Now if I have an x squared, that makes this equation what kind of equation now? What kind of equation has a square in it? We just had a test on it last week. Chapter 10. It's quadratic, right? So if we have our largest exponent is a square, it's a quadratic equation. So if it's a quadratic equation, we could try to solve it by factoring. Quadratic formula, complete the square, right? Let's try to factor it because that's the easiest of all these, right? So let's add the x to both sides. We want to put these in decreasing order. Bring everything to the x squared. Do not move the x squared. Bring everything to the x squared. That rhymed, but and then subtract the 6. So that gets me x squared plus 1x minus 6 equals 0. Let's see if this is factorable by making a table. If it is factorable, luckily for us, it will be a short way, right? Because the leading term is a 1. Y'all, we can't get rid of factoring forever, and it's so much fun. So multiply to get -6 and add to get a +1. What kind of number is that? 3 and -2. Very good. And we said this is the short way, so we could say x plus 3 times x minus 2 equals 0. So then we set them both equal to 0, right? X plus 3 equals 0. Oh, this one's not so bad. X minus 2 equals 0. Subtract 3. X equals -3. Add 2. And x equals 2. So I'm getting two selected solutions, -3 and +2. Any questions on what we've done so far? So we canceled out our radical. When we did, we had an x squared, made it a quadratic equation. We got everything to the x squared side, and we factored. Solved by factoring. Okay. So when we finish solving by factoring, we need to check to see if any of these solutions are extraneous. The way we do that, you see my black writing right there? Everything that's in black, not the red. I guess I can erase the red. The original problem is what we're going to plug those answers into to see if they're true. So if those answers are true when we plug them into the original problem, then they are a solution. If it's not true, if it's a false statement, then we say the answer is extraneous. Okay, so we've got to check our work. Okay, so first one I'm going to use is -3. So -3 equals radical 6 minus -3. So under the radical, 6 minus -3 is the same thing as 6 plus 3, right? Right? And that's 9. Is the square root of 9 equal -3, though? No. So that one's extraneous. So I like to write the word extra under the ones that are extraneous. Now, it could be that they're both extraneous, and then we would have no solution. Or it could be that both of them are true solutions, or it could be that one's extraneous and one is a real solution. You never know. You got to plug them all individually in. So then I plug 2 in. 2 equals the square root of 6 minus 2. And what is 6 minus 2? Does 2 equal the square root of 4? It does. So 2 is a solution. So come back and circle that one, highlight it, put a box around it, something to let me know this is an answer. And then you also need to let me know the other one is not an answer. Now don't scribble it out because I'll need to, on a quiz, see what number you got to start with. But let me know it doesn't work. So this one we got a real solution of 2, and then we got an extraneous solution of -3. Because -3 did not check out in the original problem. So this one really wasn't as long as I thought it might be, but we were prepared. Let me check on my lap. Okay. K is the one we're going to have to worry about. Already got the moaning and the groaning. So this one will be about the same size as the last one. Y'all going to have 20 of these for homework. Just kidding. Just kidding. All right, so what do we do first to get rid of that radical? Square both sides. So the square and the radical cancel, so we have 20 minus x equals x squared. So now what do we do now that it's quadratic? What are we going to do? Move everything to the x squared. So we're going to add the x. We're going to put them in decreasing order and subtract 20. Cancel, cancel. 0 equals x squared plus x minus 20. And it's okay that the 0 is on the left side, not the right side. It doesn't matter. All right, so we make a table. We want two numbers that multiply to get what number? And add to get what number? 1. What numbers do that? 5 and negative 4. Very good. Is this a short one or a long one, though? Short way. So, parentheses, x plus 5 times x minus 4. So then what do? Set my factors equal to 0. So x plus 5 equals 0 and x minus 4 equals 0. I'm going to subtract 5 on both sides. X equals negative 5. And x equals 4. Am I done? I got 2 answers. Am I done? No, I need to check for extraneous solutions. So I'm going to come over to the side. I always like separating my work. I'm going to do the first one, negative 5 first. So square root of 20 minus negative 5 equals negative 5. So I just plug negative 5 in for my original x's in the original problem. 20 minus negative 5 is 20 plus 5, which is radical 25. But does that equal negative 5? No. So this one's extraneous. And then I'm going to check x equals 4. Square root of 20 minus 4 equals 4. And what is 20 minus 4? Is the square root of 16 equal to 4? Yes, so that one is a real solution. So like I said, it could be that they both are extraneous, and if that's the case, you would say no solution. It just happened to be when you got one of each on these, because I'm boring and unoriginal. All right, so now for sure, if you're at the bottom of a page, I would get out another one, because this one might just take up 3/4 of it. I don't know if y'all write smaller than me. I skip spaces between every line. I know y'all probably don't do that on your paper, but I do that so we can see. But the good news is this is our last example for the day. Okay, so I got a radical by itself on the left-hand side. So how do I get rid of the radical? Square both sides. Oh, looky there. We'll worry about that in a second. So I cancel my radical, and I have 6x minus 8 equals x minus 4 squared. What does that mean, x minus 4 squared? It's not a difference of squares because I have 2x minus 4, not x plus 4, x minus 1. I'm looking for more. Yes. Here's what you do not do. And I'm going to write it over here and not over there because you do not do this. Do not. That is wrong, 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 wrong. That'll give your math teacher a heart attack. Okay? Because if you do that in Algebra 2, your teacher's going to say, did your Algebra 1 teacher not teach you anything? No, Miss Isabel told me that was fine. Happens all the time. That will give them math. You go to college, you will sure see a professor flip his lid. Or her lid. Or somebody's lid. Or your lid. Okay? That is bad math right there, okay? Got it? Got it? Okay, so x minus 4 squared means you take x minus 4 and you multiply it times x minus 4. So I would come over to the side somewhere and say x minus 4 times x minus 4. And we FOIL it, distribute it, whatever you want to call it. X times x is x squared. X times negative 4. Negative 4x. Negative 4 times x. And negative 4 times negative 4 is positive 16. Combine like terms in the middle. X squared minus 8x plus 16. We did not get x squared minus 16, did we? No. So we're going to take that and put it over here where I wrote that down. So now we see an x squared, which makes it quadratic. We want to move everything to the side where the x squared is, and we're going to combine like terms and make sure they're in decreasing order. So I'm going to subtract 6x and put it with its like term buddy in the middle. And I'm going to also add the 8 and put it with its like term buddy on the end. Is that good with everybody? So that's going to be x squared minus 14x plus what? 24. Questions so far? And now we do like we were doing. I'm going to do my table over here because I'm going to need room. So I need to multiply to get 24. Add to get negative 14. What does that? Both negatives, right? Negative 12 and negative 2. So 0 equals x minus 12 times x minus 2. And then what do I do? Set them both equal to 0. X minus 12 equals 0. And x minus 2 equals 0. And I add my 12. And x equals 12. And I add my 2. And x equals 2. Am I done? We wish, but we're not. We're almost done. What do I have to do now? Yeah, we need to see if we have any extraneous solutions. I'm going to check them both. It doesn't matter what order you do them in. I'm just going to do 12 first because that's my first one I have. So for all my x's in my original, remember my original is in my black handwriting. So I have 6 times 12 minus 8 equals 12 minus 4. And then I'm going to simplify under the radical. What's 6 times 12? What's 72 minus 8? So that's the square root of 64 equals what's 12 minus 4? 8. Is the square root of 64 equal to 8? Yes. So that one's true. So I'm going to come back and circle it, box it, something to let me know I checked that one and it works. All right. And then I'm also going to check positive 2. So I have radical 6 times 2 minus 8 equals 2 minus 4. So all the x's I put a 2 in the original problem. So 6 times 2 is 12 minus 8 is what? So that's square root of 4 equals what's 2 minus 4? Is that true or false? That's not true. Can't be a negative. So that's extraneous. So some people say, I've had people ask me before, if you get a positive answer, then it has to be one of the real ones. No, you can't just go by this because this one was 2 was positive, but it was extraneous. Okay, so you have to actually put them in and check them. And that's really as long as it will possibly get is when you have to square a binomial first. Okay, but the most part you're going to see them like those previous two were, where you can just go straight to factoring. So any questions on these? Okay, this is the end of section 11.3.